Welcome to the Real Python Podcast. This is episode 75. Can you make a version of Python that fits within the memory constraints of a microcontroller and have it still feel like Python? That's the intention behind CircuitPython. And this week on the show, we have Scott Shawcroft, who is the project lead for CircuitPython. We talk all things CircuitPython. While working with the language on several projects, I've developed many of my own questions to ask Scott. And he answers my questions about bootloaders, packages, the bundle, and Bluetooth Low Energy. He also talks about the struggle of fitting the language and board-specific libraries within tiny memory constraints. And we discuss projects, boards for beginners, and many other resources to learn more. This episode is sponsored by Rev.ai, the most trusted way to build global speech-to-text to insights, products, and workflows. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Scott, welcome to the show.
Hi, thanks for having me.
So, I've been mentioning your name a bunch of times, so I've been excited to get further with CircuitPython, and I thought this would be a great way to kind of go to the source in a way.
Mm-hmm. I am some to blame for it.
Yeah, so maybe we could talk a little bit about your background and history with CircuitPython specifically.
So my background is that I got a computer engineering degree from UW. I spent 6 years at Google. And then what I like to talk about as well is when I was at UW, I'd already done Python. And so I was a TA for the intro course.
Okay.
And I actually did for a quarter or two, I can't remember, like a Python version of the intro course because the intro course was Java. So that was like some pretty early on, like teach people how to program with Python. And so after I left Google, I spent a year doing like more embedded programming. So for those who don't know, like microcontrollers are these little inexpensive computers that are like all in one chip, and they can cost like just a few dollars or even less. And that's how I learned how to program those. And then I was looking for a job because I hadn't had a job for like a year. And I went to Adafruit and I was like, hey, Adafruit, I'd love to work for you. They were like, what do you do? I said, I'm a software person. They're like, well, there's this thing called MicroPython, and we'd love to have it on our boards.
Yeah.
And I was like, I hadn't heard of MicroPython, but of course I'd been by that time like a long time Python person.
Mm-hmm.
So combining this like newfound love for microcontrollers, which are these, very low level, like not a whole lot going on, much easier to understand sort of computers, and then combining that with Python was just amazing.
Yeah.
Yeah, and that was in fall of 2016 that I started doing that.
Okay, so we don't have to go too deep into MicroPython specifically, but that project predates it just a little bit further back, right?
I think it's 2 or 3 years. Yeah. I think Damien's the original creator of MicroPython. I think he started in 2013 sometime.
Okay.
And then it was kind of funded by that point, 2 Kickstarters that they had done really helped drive MicroPython development.
And MicroPython has its own sort of constellation of microcontrollers that it runs on.
Right. So the first Kickstarter was centered around a board called the Pi board.
Yeah.
That was produced by Damien as well. And that was running a ST microelectronics chip on it in particular. And then the second Kickstarter was an ESP8266, which is a Wi-Fi capable chip. So when Adafruit kind of brought me on to bring it to theirs, it was another chip family that MicroPython hadn't supported.
Okay.
Was kind of like my first task is to bring it to a chip that was already on an existing Arduino and already on a number of Adafruit's existing boards as well.
Okay. And Adafruit, I listened to a recent interview with, I want to call her Lady Ada.
Yeah, that's her moniker, Lamore.
Okay. And she was talking a little bit about the history, and I was like, wow, you guys are over a decade old
Yeah.
as a company, which is really kind of amazing. And then just like the scale of that business,
Right.
they've been making, like you said, Arduino based sort of boards, but
Mhm.
other microcontrollers that were programmed with like C or other languages.
Yeah. So Adafruit's history kind of originates in her dorm room. And what she found herself doing was creating projects out of electronics and then documenting them on ladyada.net, which is like her personal site. And people came to her and say like, hey, like I'd love to be able to buy all the parts for this project that you posted. And so Adafruit's origins are really in that like kitting. So kitting is the idea of like you buy a bunch of different parts, you put it together as a kit, and then you sell that. So that's where it started. And then as the company grew and Arduino came along, I think after that,
Okay.
Arduino was really one of the first things that made it really easy for anyone to program a microcontroller. And we could talk about why that is, but it's so generally Arduino is a C-ish. It is C, but there is some like tricks that they play on top of that. And while the Arduino microcontroller boards themselves were produced by Arduino, what Adafruit did is they created all these sensors, all these different sensor boards, which are just like little PCBs that have a temperature sensor, a pressure sensor, and that sort of stuff. But what Limor is really good at is not just providing the hardware, but providing everything you need to get going. So
Yeah.
the tutorials it started with, software examples to show you, and a software library to like really get you going really, really quickly. And Adafruit did really well and grew a lot, I think, in that time where they were just building on top of the Arduino ecosystem into all these different sensors and stuff.
Yeah. And I mean, that's what's so kind of great to see it kind of shift to Python in the sense that it's such much a more approachable language and not having to worry about like, sort of managing the memory and things like that and doing stuff in that range. So you were pretty excited, it sounds like, to get on board and start building this subset of the language.
Right.
You recently gave a talk at the Python Language Summit, a lightning talk. And I, obviously I don't have like a recording of that, but I talked to Joanna Jablonski about sort of a summary of it. But can you dive in a little deeper into what you were talking about there?
Sure. And I should say that I do have a GitHub repo. I think it is github/tannewt/presentations.
Okay.
And the slides are available there.
Nice. Okay.
But there's been some discussion. This is not the first year that I've been able to attend the Language Summit. They allow folks who work on alternative implementations of Python to join that as well. And a lot of the value that I think that me and MicroPython can provide to the CPython folks is really helping boil Python down to more of its essence.
Yeah.
There's been these discussions about like, what is a minimum version of Python? What are the parts that are really Python and what are the parts are outside of like what people think of as Python? And that comes out of my experience of just like, I hadn't heard of MicroPython. I tried it and I immediately could pick it up because Damien and the folks that had worked on MicroPython did such a good job of making it Python.
Yeah.
It doesn't necessarily have all the modules. It doesn't have the ColorSys module, right? But it's still Python. And so this talk was kind of highlighting the fact that CircuitPython to me is still Python. But if we compare all of the built-ins in CPython versus the built-ins we have in CircuitPython, there is a subset there. And then if you look at the standard library in particular, the subset of the standard library that CircuitPython presents is much, much smaller. And the point there is just like really trying to get the CPython developers to think about, is this actually part of Python or can we actually think of it separately?
Yeah, I talked to Brett Cannon following along his Unraveling series on his blog, where he's sort of trying to distill, like you said, all the individual components of Python and down to like, what are the different operators and how do they work at the C layer and all that stuff. And I kind of felt this theme across all the articles of, it seems like you're trying to figure out like what is Python really at its core.
Right.
And he talked about the WebAssembly idea of like, well, if we could put Python on the web, what would need to be there for it to still be Python? And one of the statements that was in the summary of your talk was, CircuitPython is 65 kilobytes compared to CPython's 29 megabytes, and it still feels like Python?
Right. 650 kilobytes, I think.
650.
We can't do 65.
Yeah, that seems a little small. Okay, good. All right, then that was a misquote. Yeah. I'll talk to Joanna. Yeah, but still less than a 1 megabyte.
Right.
Or, just over a half. And what is intriguing to me then is like, okay, well, what do you mean it feels like Python? You kind of touched on it a little bit more, but could you elaborate?
Yeah, so I think the core of it is that in the way that CircuitPython works is after you've installed CircuitPython on a device, or you buy a device that has it pre-installed, you'll plug it into your computer and it will show up as a CircuitPy drive.
Yep.
And on that drive is a code.py file. And in there is a print hello world, usually by default. And it is Python. So you can do all the standard syntax that you're expecting. You can do if statements, for loops, all that stuff. And it works just like CPython would. And then once you save, what CircuitPython will do is it will actually rerun your code automatically. Think of like the watch systems that a lot of the JS things do. It just makes it super quick to iterate, and it's just Python.
Yeah.
Math is the same, although it's a subset. You will get into new APIs with the stuff that CPython doesn't handle.
Okay.
But generally, like all of that core stuff, if you're not importing anything, it's going to be what you would expect if you're coming from CPython.
And you keep sort of trying to figure out exactly where that boundary is. Like people have been requesting things of CircuitPython.
Right.
And then I'm guessing there's a decision process. I don't know if there's like actual deliberations by any sort of set group, but what kind of goes into that? Like trying to decide like where can we continue to draw this line?
Well, we're kind of bridging these two worlds. We're bridging the Python world and we're bridging the hardware world, and we get requests from kind of like both sides of that world, of those, or both of those worlds.
Yeah.
I'm not the only person who works on CircuitPython. We have a community of folks that do. Generally, if somebody wants to add it and it fits, it's okay. There is a caveat that if it is an API that CPython has, I'm very strict about it being a strict subset of CPython, because we are trying to introduce people to Python with CircuitPython, and we want them to be able to transfer their knowledge from CircuitPython up into CPython. So we want to make sure that if you're using the math module or the sys module in a particular way, that it will just work that way in CPython as well.
So as a recent addition, I think it's recent. I don't know exactly. You can give me the timeline, but you've added f-string support, which I'm a big fan of.
Yeah.
And so in introducing that, there's like all these operators for sort of formatting f-strings. Would it include the ones that let you justify and all those kinds of fancy sort of formatting things? Maybe those are already built in as standard string formatting, and f-strings just sort of expand it. But
I'm not sure. And this goes back to where we try to be a strict subset. So, if it works on CircuitPython, then it should work in CPython, but the reverse is not true.
Okay.
And the f-string stuff was added by a community member, so thanks to them for adding it. But yeah, we try to be a strict subset. It may not, everything in CPython may not work.
Right.
There's a lot of details there. And I do know that under the hood, the way that our f-string support works is it actually gets translated into like a string format call.
Okay.
Under the hood. So I would assume that it's kind of limited by what the string format mechanics can do.
Okay. That's cool. Like I understand the challenge there and wanting to not have to introduce a lot of extra code to make it work. So that's nice.
Well, it does get to something that like I've talked with Brett about with this minimum viable Python idea is like, if we had a test suite for PEPs, right, that are encoded in the same, like this is part of the minimal version of Python. Here is a test suite for f-strings, right? Like then any implementation that adds or supports that PEP would be able to say like, yes, we're compliant, or no, we're not. Could be a really great resource for alternate implementations of Python.
Yeah, because there's other, obviously there's MicroPython that CircuitPython builds on top of.
Right.
And now, as I think you were saying in a recent interview, that there's a little more divergence as it's kind of gone along from, like strictly what's in MicroPython?
I mean, generally, we've actually recently done a better job of being closer aligned with MicroPython.
Okay, great.
I took, I don't know, a month or more to like get us 2 years updated.
Oh, okay, wow.
So there's not a whole lot of differences in the like Python VM side of things between MicroPython and CircuitPython. And Damien and the MicroPython folks have done a really good job of having test coverage for that VM side as well. So they've done a really excellent job on the VM core, and we generally just inherit all of that from them. Where we diverge a lot is more the workflow. So like MicroPython won't do the auto reload thing that CircuitPython does. We're very strict right now that we're either like USB or BLE only workflows, and we want to make sure that everything's like really consistent across all of the devices we support. So there's a lot more variation in the like, how do we bring the hardware world to Python side of things rather than like the actual like Python engine.
Yeah, I guess we could dive into that a little bit. Like I've been dabbling with a variety of boards, and initially trying my own hand at like hybridizing some of the projects. And so
it's a great way to start.
Yeah. Well, and then I talked to Nina and I was like, maybe I should just really play around with this Playground Express a little bit more, and kind of like learn sort of the library there. And that brought me to this question. And so when a person gets a board from Adafruit, like let's say the Circuit Playground Express, and they want to get started with it, there's no guarantee exactly when the code was loaded onto this the circuitry that's on there. So you need to go through the process of updating it with the bootloader, right?
Yep.
Okay. And so I would go to this circuitpython.org, find the board, and there's like a designated page.
Yep.
And then there's like two primary downloads, the bootloader and then like the CircuitPython, I want to call it package, but I don't know if that's the right word to use for it.
Yeah, so I think it's for those folks on the Python side of things, we should talk a little bit about bootloader.
Yeah.
So a bootloader, and this is where, in my opinion, a lot of the Arduino innovation came to, is so the bootloader is a piece of code that is on your device that its only job is to load other code onto it in another piece of like in a separate piece of storage. And typically the device will protect the bootloader from overwriting as well. So it's like very easy way to guarantee that you can like load new code onto something. And on the Circuit Playground Express and a lot of the other boards from Adafruit and other companies as well, because it's open source, there's a bootloader called the UF2 bootloader, which shows up as a drive, just like the CircuitPy drive, except it's named something else. And then you drag over a .uf2 file, and that will flash the contents of that file. So they're both stored in Flash, the bootloader and the other code. And so the bootloader will write to the other section of Flash with that new code there.
That's pretty cool that it just is sort of, I don't know, watching for it in a way that when this UF2 code is dropped onto this thing that looks a bit like a thumb drive.
Yep.
Like you said, it recognizes, oh, hey, there's this new file.
Right.
And then it ejects itself safely.
Yep.
And then does the update, right?
Yeah. So kudos to the Microsoft team who came up with this, actually. They came up with the UF2 format. And the secret to the UF2 format is that each individual, so when you drag a file over USB and it gets written, it's written in 512 byte blocks.
Okay.
They may not be in order, but they're always in those blocks because that's kind of the protocol for USB. And so what they did with UF2 is they just said, what if we just made every 512 byte block standalone? So each one of them has a signature that says, hey, I'm part of a UF2 file. Each one of them says, I'm block X of Y blocks. So the bootloader can keep track of like, oh, I'm looking for 100 total blocks and I've gotten 99 of them.
Okay.
And each block knows where it goes in flash memory, so it can be written as it comes in as well, which is important if you have like more flash that you're writing to than the amount of RAM that you have available, for example.
So in this case, it reboots that, which in a way sort of updates the, I want to call it the firmware of the actual board itself.
Right.
And then to make it specifically ready for CircuitPython, you would get the latest, version
Yep.
of CircuitPython, and then there's a specific package that comes in another UF2 sort of bundle, and you drag it onto it again, and that's when it sort of flips the switch and appears, like you said before, is it CircuitPy?
Yeah, by default.
Is the name of the drive?
Yeah, by default.
Yeah,
Yes.
okay. Okay, cool. So this is where my question comes, is when you have a specific board,
Yep.
And I don't know, maybe this isn't the best analogy, but like kind of a Macintosh kind of thing where, they are making the operating system and they're making the hardware. And so you kind of know what hardware this thing has. In this case, you do have to specifically download this collection. But by grabbing the CircuitPython bundle for the Circuit Playground Express, it includes a bunch of sort of sub packages for the specific hardware that's on that board. Like this board has a thing called the NeoPixel.
Mm-hmm.
It has a motion sensor. It has obviously it has a USB port because it's plugged in via USB. But then you're adding additional libraries. Again, things that you said are not going to be part of, CPython per se.
Mm-hmm.
The things like to be able to have it act like a keyboard or have it talk USB MIDI or what have you.
Right.
Am I explaining all that right?
I think at this point I would avoid the term bundle.
Okay, sure.
Because we use that for something else.
Okay, great. Yeah.
But I think what you're getting at is that, so the UF2 file is a version of a binary. So imagine you were compiling CPython and you get a .python or python.exe out of it, right? Like that's what the UF2 file is equivalent of. But what's different is that we build a different version of CircuitPython. We actually build like over 10 versions per board.
Okay.
Because we also do translations. But basically, we produce a lot of different of those binaries.
Yeah.
And we do have some control about which native modules or which modules are built into each binary. So, for example, if we don't have flash space, for our NumPy equivalent is Microlab, and shout out to Zoltan for creating Microlab. But like typically we, especially on the SAMD21s, and the Express is one of those, like they have a total of 256 kilobytes of flash space.
Okay.
And it's really hard to fit everything into there. So we have to be a little bit more rigorous about which built-in modules that we support on those boards.
Yeah, that makes sense. And so one of the things that you do is you start to do something beyond the print hello world.
Right.
In there is you want to access, things that are part of this little board.
Mm-hmm.
And I've seen a divergence depending on the tutorial sometimes, which I was a little confused by, where some are saying import board, which is sort of a general term for like, okay, you're going to talk to this hardware and the pins or the physical connections that are on it. And then occasionally I've seen for like something like the Circuit Playground Express importing, the Circuit Playground Express and then like giving it like an alias as CP or something like that.
Right.
Are you accessing different parts of the binary package underneath there then?
Well, so I think it's a matter of abstraction layer.
Sure.
So the CPX thing that you're referring to is like a big library that's written in Python, and what its job is to abstract everything away from you. So all of the things that are on the board will be initialized for you.
Okay.
Whereas what the board module is doing, which is a built-in, is it's really just doing a very minimal layer on top of the standard APIs. So largely what board is it's just mapping the names of pins on the board that are labeled on the board back to the pin objects that are like brought in by the microcontroller. So the microcontroller says, this is pin PA00, that we've on the board, on the circuit board itself, it's connected to something that's labeled A1. And so in the board module, you'll get board.A1, and then that will equal the object that represents the internal PA00.
So then, by contrast, when you've done something with importing via the CPX version of it,
right.
it's abstracted that and maybe has slightly friendlier naming and
Right.
less direct accessing the modules. Like it might have like I noticed one of the things with the accelerometer functionality, there's a object, I don't know if it's object or method, but there's something called tapped.
Right.
And I'm guessing that that's addressing that particular part of the circuitry then.
Right. So what it's doing is it's saying, okay, well, what is the standard bus that I'm talking to the accelerometer on? So that will be an I2C bus. Let me run the initialization code for the sensor.
Yeah.
And then I'll do that all when you say tapped or when you create the CPX object, which happens on import. You actually end up creating it implicitly with import, kind of like a singleton, because obviously you only have one copy of this board.
Right. Okay.
And then what tapped is doing is it's using the library for the accelerometer under the hood to say like, hey, have I been tapped?
Okay.
And kind of like hooking that all together for you. And that's like the CPX library really is like one of the highest levels of libraries that you'll get in CircuitPython, where it's like,
yeah,
there's the top tier of like, I have this board and all this stuff is connected to it. Let me initialize it all for you and give you like very high level abstractions of what you want to do with it. And then below that, you have like all of the drivers for different things that are on the board. So you could initialize those yourself as well. And then those drivers talk down to the native modules that say like, here's how you do I2C transactions. And at that level, I have no idea whether it's an accelerometer or not.
Yeah. Okay. Yeah, that's cool. Like I think about that with, as another example, about a year ago, I bought the Neo Trellis, sort of all in one. I guess it's maybe the M4.
I think so. Yeah.
So it's the one that has all the, was it 4x8 set of
right
of buttons. And so, I did a couple basic projects, kind of more on the Arduino side with it, doing stuff in C. But I was really wanting to play with it in CircuitPython, and the new product came along, the 20, is it called the RP2040?
The MacroPad.
MacroPad, yeah.
Yeah,
right.
So the RP2040 is a particular microcontroller from Raspberry Pi, but we made a MacroPad out of it.
Yeah, and that's a really neat project. And so I've been watching a couple of projects kind of come through there, and I was like, well, okay, I could do some of those similar things with this board and so forth. Like I was thinking about making it be like an Ableton controller, control something like live and send out MIDI commands with it. And so I was able to get it, sending MIDI and, lighting up the NeoPixels inside of it.
Awesome.
and so forth. Yeah. So I was having a lot of fun with that. I just need to kind of go a little bit further. But through that process, I was watching
John Park.
Yeah, John Park. He was doing demonstrations.
He loves
with
MIDI.
Yeah, he does. Yeah, and I'm totally a MIDI geek. That's partly my background.
Nice.
Is doing lots of music stuff, and I saw two different demonstrations over the last couple of weeks, and one he was addressing a lot of things directly from the board or directly from like a USB MIDI, and then in another stream there was a separate like edition where he was able to import just MacroPad, and a lot of those things were built in kind of in the same way that you were talking about with the CPX library for the Circuit Playground. So is that something that people kind of just take on board and say, all right, I want to do that. I want to like figure out how I can combine these things and abstract them? I
mean, it's something that for kind of our flagship products, that's what we'll do is we'll do kind of the highest level of library that puts all the pieces together for you, which is what the MacroPad library is. It's the same kind of tier as the Circuit Playground Express library that you were talking about earlier.
Yeah. Through that, I was like kind of going in and out of GitHub and looking at the libraries and trying to learn as I kind of went along. And often you may need to add a library, I feel like. And in those cases, then you can go and get sort of the compiled version of like like all of the different types of packages. I'm not probably speaking very well here about what that is, but like for the general support of CircuitPython for these different hardware devices, there's like a big file that you can get that has
Right. So
all of them in there.
yeah, so this is what we call the bundle. This is why I was like,
Okay, that's
maybe
the
let's
bundle.
not call it that. So
Okay.
for Python folks, the way that you install a library in Python is pip, right? Like
Yeah.
pip is the way you do it, and MicroPython has for a long time had micropip, but the challenge with having something on the device is that a lot of the devices don't have network connectivity.
Right. Okay, that makes sense.
So when I was thinking about how we would do packaging in CircuitPython, there's kind of two pieces that led me to this world where all we do is we provide a zip file with all the libraries in it.
Okay.
That's what the bundle is it's just a automatic, like grab all the libraries we know of, put it in a big zip file. It's not even that big. So like when the bundle was first created, we could actually just fit all the libraries on the flash.
Yeah. Okay.
And then we just made more and more libraries, and that stopped being true, unfortunately.
But it's still under like, I don't know, what, 6 megabytes or something like that?
Yeah, it's still not that much. And maybe some of our biggest boards have like 15 megabytes of flash storage, but
okay.
Most of them don't. So there's been a couple tools recently that our community has created. Actually, one in particular, it's called CircuP, CIRCUP. It's kind of like the pip equivalent for CircuitPython now, where
Okay.
it can take a look at everything that's on your USB drive, and it can offer to update them for you. Or if you need to install something, it can install it and all the dependencies.
Okay.
Because we do actually, the libraries are now generally, most of them are also available on pip now, because we do have the ability to use them in CPython on Raspberry Pis and other single board computers.
Yeah. So like on a Raspberry Pi, it's running Linux.
Mm-hmm.
And so you could have your Python installation running and get to a prompt and use pip to add them. Okay.
Yeah, just for that. But that's not for a separate CircuitPython device. So that's if you're running. So we have a library called Blinka that is this layer between how Linux does hardware stuff and the CircuitPython APIs that we established with the microcontroller level CircuitPython.
Okay.
So our libraries work both places now, and it's been quite the testament to our hardware APIs that we were able to kind of move this ever-growing catalog of libraries from microcontroller land up into Linux CPython land as well.
Yeah, I imagine that's a pretty big project to kind of like migrate all those different pieces.
It wasn't that bad actually, because by being a strict subset of CPython, we kind of know that we're going to be able to move upwards.
Okay, good.
The one tricky spot we had was like due to the way that like Linux exposed some particular thing. Like we could do it on a microcontroller, but we couldn't really do it on Linux. So there's like one specific API change we had to make, but besides that, it was actually pretty straightforward.
So going back to the bundle in
Right.
this file, zip file that you can uncompress.
Yep.
The idea there isn't that you would grab that whole thing and toss it on the board. Like we said, there may not be space for that.
Right. It doesn't work anymore. It used to.
So in this case, let's say I need something specific that this thing's going to do.
Yep.
When you get your CircuitPy drive name, not only does it have the code.py file that runs in it, there's a subfolder, a lib.
Yep.
And that's where I would add these additional pieces of code. And they can be, I was a little confused by the extension of mpy. And then I think I listened to your conversation and how that is a MicroPython file that's compiled version. Is that right?
Yeah. Yeah. So you can think of it as the equivalent of like a PyC file.
Okay.
Where it's like the VM has like done its parsing and tokenized it and created bytecode. And so that it doesn't have to do all that processing again, it like writes that bytecode out.
Okay.
And that's what the MPYs are for. And MPYs are really nice for, again, the Circuit Playground Express only has 32 kilobytes of RAM.
Right.
And so that parsing process can take a lot of RAM as it happens. And so MPYs are nicer in that they have they require less RAM to import than PY files do. So you end up with the equivalent Python code in memory, but you don't like the maximum RAM use is less if you're importing an MPY versus a Py file.
And it's going to kind of save on both sides then of like storage in that area of the drive, and then also the usage in the memory. Okay.
Yeah. So if you have a SAMD21 board, I recommend it, but you could try on the RP2040, which has 256 kilobytes of RAM. You could try just using the PY versions.
Okay.
That's easier because then you can see the source, right? Like you can actually edit it and modify it and stuff.
Yeah. And so that, as I was kind of going down that rabbit hole, I was like, actually looking at like requirements.txt files for these different things. It's like, okay, this builds on this and this builds on this. And what I ended up doing is, unfortunately, I guess I got a little lost along the way, and I wasn't noticing all these things that were like included. And so I was like re-adding the USB library or the USB HID for doing like keyboard stuff, and I'm like, oh wait, it already has that.
Yeah, so the Circuit Playground is one of the few boards that's a little weird. Because it's so RAM constrained. What we've done, it's so RAM constrained, and we know a lot about what is on the board already. There is this other process called frozen modules. And what this is doing is it's taking a Python library, essentially doing the MPY process, but then storing it in Flash instead.
Okay.
And by doing that, we can use the Python code from that library without incurring a RAM overhead. So if you import something that a library that we've frozen in, we save RAM, which means that we can do other stuff instead. So the Circuit Playground Express, which is like the 32 kilobyte RAM threshold, is like the minimum that we do. We won't go below that. The experience in CircuitPython gets better the more RAM you have generally. And 32K is quite small now.
Yeah.
So anybody looking at a Circuit Playground, I recommend the Blue Fruit instead, which has more RAM.
Rev.ai, the most trusted way to build global speech-to-text to insights, products, and workflows. Trained on more than 50,000 hours of human-transcribed verbatim speech data covering a wide range of topics, Rev.ai offers developers unparalleled speech recognition accuracy, with word error rates lower than similar solutions from major players like Amazon and Google. Your first 5 hours are on us. Try us out today at Rev.ai. That's rev.ai. I guess there's kind of two divergent things I wanted to kind of dive into from there next, which is actually programming it. One way you could theoretically program this is, it's a text Python file, that you could open up in a text editor. And I think you had some suggestions of certain ones that you shouldn't use because of the way they save stuff.
Right.
But, like if you use something like Sublime Text or whatever, you could use that. And then I felt like the integration with Mu is really great. Like,
awesome.
I was really impressed with how that works, and the ability to kind of open up a sort of terminal, right, in it where you can kind of see the code running.
Right.
That part was really powerful, and it kind of gives some basic key commands too for like if you need to reset the board. And I was playing around with like the touch sensors, and I think you were saying that how like when it does an import of the library, it does a calibration of a lot of the circuits that are on it, and so occasionally you need to do that, right?
Yeah, the CPX library does. Yeah.
Okay, and I just think that was really cool. And then again, this, I don't know if that's part of the bootloader thing or this watch process where it knows that you've hit save to sort of start, rerun the code again.
Right.
Yeah. How's that done?
So what CircuitPython is doing, so this is, the bootloader doesn't know anything about this.
Okay. All right.
CircuitPython is pretending to be a USB drive, or it is a USB drive. Like that's the way it works. But what we see is, what we get is we say, oh, the host computer just wrote to the file system. And we have internally in CircuitPython just a countdown timer that says like, okay, every time you write, we're going to start the clock and say 700 milliseconds from now, we're going to restart the code. We don't care what file it is. We have no idea what file it is because the USB protocol is actually like underneath the file system.
Oh, okay.
It's block-based instead of file-based. And so what we just start this timer, and then, if you're writing a big file and there's multiple blocks that's got to write, like that timer just gets reset. So you don't necessarily get a lot of auto reloads, but you may actually, depending on your host behavior, you may actually see more than one reload happen. And it's possible, although it's not very common, to see like a syntax error happen in like one of those reloads as the like host OS writes the rest of the file.
Yeah, I noticed that like I was going through one of the tutorials and I was dragging these very small audio files onto it because the device has a little speaker.
Yep.
And as I dropped them on it, it would restart the code, even though I wasn't really playing in the code. It was just moving files onto the drive itself. So
right.
And that's part of that whole process. Okay.
Yeah, it just has no idea what you're writing.
You touched it.
But I mean, like, imagine that you are. Yeah, there's a scenario where like, yeah, you're changing the audio file that you're actually playing back, and you would actually get that feedback of like, oh, now it's playing the other file.
Yeah.
Or the new version of the file.
Okay. And so one of the things that I haven't followed this thread, but I was watching the Twitter feed and kind of seeing stuff come up, and I bought a Bluetooth board mostly because I have this foot switch project I'm going to build. This is sort of like a YouTube controller for a guitarist, so they could be hands-free controlling rewind and playback and pause and stuff like that.
Right.
And it could do whatever else you want, once you get it doing keyboard stuff. And I was like, man, I should make this Bluetooth so I could do it on an iPad or a phone or what have you. I'm like, this should be fun.
Right.
But then I saw, and I'm not sure how far along this is or where it's at, but the idea of programming it via Bluetooth, like actually talking with like a code editor to it wirelessly. And
so you got a Bluetooth board, which is really exciting. I've been wanting to do this for a long time. CircuitPython's goal is to bring programming in any form to folks who haven't programmed before. So one of the challenges with that goal is just access and access to a laptop or a computer in particular. And what a lot more people have access to is a phone or a tablet.
Yeah.
And so what I wanted to do is like USB support on a phone and tablet is not great.
No, it's not.
So the real way, or a better way to connect to one of those two things is actually over Bluetooth Low Energy, which is called BLE.
Yeah.
And the APIs for that have gotten really good. So this summer, I've like revisited some work I did a few years ago about making it possible to do kind of like the two core pieces of the CircuitPython workflow, but over BLE instead of USB. And those two pieces are transferring files and getting the serial feedback back. So the serial output and input to the device as well. So been working really hard with that and made a lot of progress this summer. But the challenge with Bluetooth is that there's no standard for those two things.
Okay.
Which means that there's not like an app that we could just use by default, regardless of like what platform you're on. Like it's all new. And so the challenge, we've gotten so far with USB because we've stayed very much in the standard parts of USB.
Okay.
So like we do USB mass storage, which is what makes it show up as a drive. And we did it in a way that it just works.
Right.
So getting all that going with CircuitPython was like, oh, once we get the device doing it the way that a USB stick you use, like it just works after that. Whereas with Bluetooth, like, okay, we've got the Bluetooth side seemingly working with like some test code that we've got on the other side, but like, how do we make the host side now easy to use and accessible on a bunch of different platforms and all this stuff? So it's a long-term goal of ours to bring programming to phones and tablets, and BLE is a great way to do that, but it's just it's a lot of work.
Okay.
So we're working on it.
Moving forward, yeah. Okay.
And I need to get back to that this week.
Okay. Yeah.
I took a little bit of a break because it's pretty brutal work.
So I have a itsy bitsy board that does the Bluetooth. I forget it's a long list of numbers.
NRF 52840.
Yes, that's the guy.
Yeah.
And because I used the other version for my first version of the foot switch.
Uh-huh.
And then I bought the battery charging little board, but then I noticed that it is primarily designed to sort of sit in this area of the board where there are buttons. And then I'm like, well, okay, how often do I need to access those buttons? Is that something that with BLE that, I'm used to connecting headphones or other Bluetooth devices or a keyboard.
Mm-hmm.
Is there like a similar pairing process where I need to press this button on the board to have it say, hey, I'm here, and wave hi? Is that something similar with these boards?
Yeah.
Bluetooth?
Yep. Yeah. So that's the standard parts of Bluetooth that we get. So the way that it's working currently, and this is subject to change because it's really early.
Okay.
But we used to be very strict about CircuitPython being USB boards only because we had this great workflow over USB that we were teaching everyone. But there are some boards that we would like to support that don't have USB but do have BLE. The Microbit V2 is like the canonical example in my brain. So we've just recently loosened that restriction, and the behavior right now varies a little bit about whether you're a board that does both or a board that only does BLE. So if you have a board that only does BLE, the way it'll work is that it will just go into that discovery process by default.
It gets powered up and it turns on.
It gets powered up. It starts advertising. Advertising is the term for BLE saying, hey, I'm here. Here's a little bit of information about me. You've probably seen those lists of like names of devices nearby.
Yeah.
And those names are from the advertisement.
Okay.
So we'll do that by default on BLE, but for the ones that have both, we won't do that by default. So what you'll do is after you hit reset, it will blink yellow, which is for safe mode. So the safe mode is a mode where CircuitPython starts up but doesn't run any user code. And that's a way to salvage in case you actually tickle a bug that like is fatal.
Oh, okay.
It makes it so you don't end up in a boot loop or a crash loop. It gives you access to the drive over USB in safe mode, but it won't run your code. That ideally, your code is the reason that your code tickled a bug in our code that was fatal.
Yeah.
So that's safe mode. And then for these boards with BLE, they'll have a second phase of that blinking that's blue and faster. And if you hit reset during that phase, what you'll do is it will start up again and it will advertise.
Okay.
And then once you advertise, you can say connect on your phone. And then after you connect, you can pair. And pairing is the process of getting a secure connection and also remembering each other so that next time you can auto connect.
Right. So that at that point, if I power on the device, it just connects to the computer or tablet or what have you. Hopefully. I can go and look in the menu and check.
Yeah.
And via BLE, the types of protocols that it could speak, it could act as a keyboard.
Correct.
It could act as a MIDI device, which we were talking about earlier.
Yep.
Are there other areas of the BLE standard?
There's a pseudo standard for the serial stuff that we're using as well.
Okay.
The device manufacturer that we use is called Nordic, and they have kind of a standard example that lots of people use for the Nordic UART service. A UART is a more technical name for serial, but there's not a whole lot. There's also for iOS, we have examples where you can get the notifications from your phone over BLE.
Okay.
Which is pretty neat. You can also get the current time from iOS that way as well.
Nice.
So there's some neat things there, but a lot of people just use it for HID, which is like the keyboard, mouse, gamepad sort of stuff.
Yeah, those seem to be the majority of the projects that I've seen use it, and actually the area that I'm most interested in and start playing with.
Right.
Because I can think of I have a lot of music things that are iPad or phone based also, and
right.
Yeah, and MIDI is kind of a nice protocol because it is rather simple also. in some ways it's simple, but at least it, as far as transmitting information, it doesn't require like mass bandwidth and stuff, which is kind of nice. Yeah.
Yeah, I mean, BLE does not have a lot of bandwidth, although
right.
with the newer versions of BLE, they have ways of getting more bandwidth out of it.
Cool.
But it, first and foremost, it's meant to be low power.
This week, I want to shine a spotlight on another Real Python video course. It covers a subject directly related to this week's episode. It's titled Getting Started with MicroPython. The course is based on a Real Python article by Chris Garrett, and in the video course, Darren Jones takes you through the history of MicroPython, the differences between MicroPython and other programming languages, the hardware that you'll use to build devices, and the process to set up, code, and deploy your own MicroPython project. As we've covered in the show, CircuitPython builds on top of MicroPython. And if you're interested in using Python to program microcontrollers and build projects, this course will get you up and running with MicroPython. Real Python video courses are broken into easily consumable sections and include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. You said you were very interested in microcontrollers. Would you consider yourself a maker? That was something that I was very interested in, 10 years ago or before. I was like following kind of Make Magazine and, the idea of, crafting and DIY projects and stuff like that.
Yeah, I think I do consider myself a maker. I found Adafruit after I had bought a house. I wanted to have a bunch of sensors around the house to tell me like temperature and humidity over time and things like that.
Yeah.
So that's really how I found Adafruit. And I've always dabbled in the hardware side of things. So for example, the thing I was doing in the year between Google and Adafruit was like creating PCBs for drone flight controllers. So I was doing electronics on that.
Oh, okay.
So I do enjoy dabbling in the hardware side, but I have been in the software side so long that I'm like way more effective. And hardware is really hard.
Yeah.
Software is great because you can scale once you have something done once, generally. Whereas hardware, like if you actually want to start a hardware company, you got to build the stuff.
Yep.
Right. Like you have to build each unit. You have to track like all the different pieces that went into it and how much they cost so that like what your profit was and then you have to sell it to someone and support them. And maybe it like got knocked in the mail and now it doesn't work, or they haven't managed to get it working on their computer or things like that. Like the hardware world is really hard.
Yeah, I've been watching Stargirl over the last year and a half, go through all of that with Winter Bloom.
Yeah. Stargirl.
It's pretty intense.
Yeah. And like now, like even in the last year, this new chip shortage, it just made it that much more difficult.
Yeah.
We're very lucky that, Adafruit's investment in CircuitPython has meant that we support a lot of different chips. And so we're able to take kind of the Adafruit product line in the direction of chips that we can still get.
Yeah. Yeah.
And still use all this software that we've created that runs on CircuitPython as a result.
Yeah, I want to get a macro pad, and they're all out.
Yeah,
so I got my name on the list, so I'll get notified. But that looks like a perfect little product to kind of do these sort of musical and other keyboardy kind of projects. And
yeah,
I like that it has a display. That's very cool too.
Yeah, so for folks who don't know, a macro pad is like a mini keyboard.
Like a 10 key looking kind of thing.
Right. So this is like it's got an OLED screen in the upper left-hand corner, and then it's got a rotary encoder, which is like a knob that you can like spin infinitely in each direction. And then it's 3 keys wide and 4 keys tall. And each key has a RGB LED we call NeoPixel underneath it as well. So that's kind of what a macro pad is. And you can use it for doing all sorts of like keyboard shortcuts and things. And I just set mine up so that I can just play and pause my Spotify based on a key.
Yeah, totally.
It's like been really handy.
Yeah. That's there's so many neat little projects, and then the idea that like it doesn't have to be designated for its life. The reprogrammability is so cool.
Right. Yeah.
So, are there other like hardware projects or pieces of gear that excite you in this realm right now that Adafruit's offering?
I mean, the MacroPad is like the thing that we're pretty excited about right now.
Yeah.
The thing that I'm excited about that I want to do at some point, like the BLE stuff is a long-term thing I'm very excited about, but like I'm in the weeds of it right now. So I'm like,
Sure.
somewhere between excited and not excited. One thing I really want to do is I like pushing the boundary between like Linux Python and CircuitPython and microcontrollers. And one thing I want to do to blur that line even more is I'd like to bring CircuitPython to the Raspberry Pi, but that means no operating system. That means just like CircuitPython itself.
Okay.
And it in my mind, it occupies a space that's like very similar, like it's a modern version of like a single task operating system, like what the Commodore 64 had, or the Amiga.
Okay, you turn it on and it's ready to go.
Turn it on, you get a Python prompt. It plugs into your TV, and this is why the Raspberry Pi is the thing that I'm thinking about. Is like it has really good HDMI support.
Yeah, it does. Yeah.
So
I bought a 400 recently. The keyboard
exactly,
all-in-one.
exactly. Yeah. So like imagine plugging in a 400 and being very much like a Commodore 64, where it's a keyboard and a computer all in one. You plug it into your TV, and now you've got a computer. And I think CircuitPython's strength is that like there's a lot fewer layers between you and the hardware.
Yeah.
And I think that's really good for people who are getting into computers. So I think it would be really interesting to see how people use CircuitPython in that kind of environment of like, it's going to be really awesome because it's like gigs of RAM and like very, very fast. So it's going to blow people's minds in CircuitPython who come from a smaller microcontroller.
Yeah.
But then at the same time, like I think people are going to be like, wait, I don't have a web browser.
Right.
And that's really where like Linux does a good job of like multitasking and desktop environments and things like that. So I'm excited to push that boundary.
Theoretically, could that happen just by exchanging out the card, that you boot from?
Yeah. So the Raspberry Pi usually runs its operating system off the micro SD card.
Yeah.
So yeah, it would just be, hopefully I'd bug the people I know at Raspberry Pi to say like, hey, put us in your imager or whatever it's called. So that
there's choices, right? You can
select Raspbian or Ubuntu or whatever, or CircuitPython and flash that onto your SD card.
Yeah.
And then you would get CircuitPython on a Raspberry Pi. One of the challenges is like we'd still like this USB or BLE workflow to work, and a lot of the Raspberry Pis themselves don't expose like the USB device side.
Huh.
Where they act like a USB device. What they have instead is USB host, where you plug a USB device into it. So there is some weirdness there. But they've come out with the Compute Module 4, which is a really neat little version of the Raspberry Pi, but kind of in a module form. So we could create, or people have created kind of boards that those go onto that do expose the USB device side.
Okay.
There's a crowd supply called PyUnora, which is done by Timon, who's a person I met at a SuperCon, I think, and we got talking about this idea, and so he made it happen. And so there's a kind of Arduino form factor, so the Arduino Uno form factor, which is also in Adafruit land, the Metro. There's a version of that, but it fits barely a Raspberry Pi 4 compute module instead.
Wow.
So it's very much like blurring the line between like single board computer and microcontroller, which is really neat.
Right. And so that potentially could have that like HDMI out and stuff too then?
Right. So it does have a full-size HDMI port on it.
Okay.
But it also has a USB port that is a USB device. So you could treat it like a Metro, but you get HDMI out.
Wow, cool.
And you could have like Arduino shields or something on it as well. It would be, I'm excited to push the boundaries of what, like where that is. And I'm excited to learn about how those systems work, because those are like a different tier of system on a chip.
Yeah.
And I'm excited to start to learn a bit more about like Cortex-A ARM chips instead of Cortex-M.
Okay. And that's like a whole other like scale.
It's a whole nother world, because like Cortex-A's are very much what you would expect to find in a phone or a tablet. And so they're really meant to run Linux. So a lot of the documentation is just like, here's our Linux kernel. Here's our Linux kernel. And like, there's no real great docs because there's not a lot of people that use it kind of outside of that environment.
Yeah.
Which is what I would be trying to do. But
so one of the other areas I was thinking about was, do you have suggestions for, I'm guessing the Circuit Playground Express is still a really good board for somebody to start with. Is there any other suggestions as like a good starter board?
I would start with the Circuit Playground Bluefruit if it's in stock.
All right. More memory.
Not only does it give you Bluetooth, but it does also provide you with more RAM.
Okay.
Which really helps. And it's faster as well. So it's like 64 megahertz and it has floating point, whereas the Express doesn't. So it's definitely snappier.
All right.
The Playground Express is fine, but we've had to play some tricks in order to be able to do more complicated projects or complex projects where you'll have a little bit more headroom on something like the Circuit Playground Bluefruit.
Okay.
Which is an NRF 52840 chip.
And I was asking you this kind of offline, but before we started, did you have a suggestion for, are they called feather wings? I'm trying to think of like the appropriate name for these additional like add-on boards that you can kind of attach to the microcontroller to kind of give it.
Mm-hmm.
Like I saw an example of like a board that, you know, adds a lot of connections for touch sensors or things like that. Are there like suggestions for ones to do like higher quality audio or something?
Right. So I think as a software person, I think we should think about hardware form factors as APIs, right? Like a feather is a board with particular locations for all the different pins and some constraints about what those pins do. So a feather wing is an add-on that like is designed to interface with that API that a feather has. Another common kind of form factor that we have at Adafruit is called Stemma QT, which are these kind of 1 by less than 1 inch boards that have these little plugs on them that are 4 connectors. Those use I2C, and those are pretty common for sensors and things.
Okay.
And that's also it's interoperable with SparkFun's Quick thing as well.
Okay.
If they don't fall into those like particular form factors, it's generally known as like a breakout board.
Okay.
So it's a breakout board I would define as like, it's a PCB, which is a printed circuit board that has a chip that doesn't do anything on its own, but needs to be controlled by something externally.
Okay.
So that's kind of what a breakout board is to me. And so for audio specifically and for higher quality audio, like you're asking for, there's kind of, when we were talking about this, you were talking about the audio on the Circuit Playground.
Right.
And then the audio on the Neo Trellis. And in both of these cases, the way that they work is it's the microcontroller itself has a peripheral called a DAC, which is a digital to analog converter.
Right. Okay.
So it's taking the digital values of the audio. So audio is a series of values over time that are like changing the position of a speaker to produce sound, or the microphone is moving and like recording the numbers in input wise.
Yeah.
So what a DAC does on the microcontrollers is it's converting those numbers into voltage values that are then being played back either in your headphones or in the little speaker that's on the device.
Right.
But the DACs on these low cost microcontrollers are not spectacularly good. They're typically cataloged by bit resolution, so like 10 bits of accuracy, 12 bits of accuracy.
Yeah.
And then that's one dimension of how well your audio will sound. And then the other dimension is like, how many times per second are you actually updating that value? So that's like, date myself a little bit, but like you're downloading a song off Napster.
Right.
And do you want the 320 kilobits version or the 192 kilobit version or the 44.1 kilohertz version?
Right.
Typically, the higher your sample rate, the better your audio is going to be. And the chips, a lot of the microcontrollers that we work with have trouble keeping up with high bit rates. So for better audio, what you'll want more speed and more RAM, which will give you higher bit rates, higher sample depth, so how many bits you have per sample. And then the DACs, I don't know of any great DACs on the devices themselves, so I would suggest looking into an I2S DAC. So I2S is a protocol for audio between a microcontroller and a dedicated chip that does that digital to audio conversion.
Okay.
And they'll do a much better job of it than anything that I know of that you'll get built into a microcontroller.
So it'll do the job of potentially ADC, analog to digital conversion, bringing sound in potentially, or one could be designed to do just the digital to audio conversion out.
Right.
And where you would use the microcontroller would be for sort of sending some of those commands to it,
right,
but not necessarily the actual conversion part, which it might be too slow to do.
Right. So it's gonna send the digital data for what the sample value is. It's not going to send a voltage, right? It won't have to do that conversion.
Okay.
Now, that's generally for audio out, and you can get things that do audio out that way. But typically, for microphones now, you can actually get microphones that will just output audio or output I2S or a digital sort of sample directly.
Nice.
But you still have the challenge of keeping up with all that data.
Right.
And it's really hard. Like, another coworker of mine who works on CircuitPython, Dan, has been spending the last, I don't know, month at least, trying to run down some audio playback problems on the RP2040 that we've been having. It's quite a challenge. It's concurrency. It's, loading samples from this place and putting them in RAM, and then letting the output thing like get it as it needs it, and like making sure that you can keep up. And it's tough.
Yeah.
It really makes you appreciate that, like, computers are really just moving numbers around, and
yeah,
how well it can do it. And I enjoy it. I enjoy working at this level because it really, in microcontroller land, like, computers feel like machines still.
Right. Okay.
Whereas if you're in Linux land, like, you're so far from the machine that abstraction's great, and I love abstraction, but I also like I was just debugging something today where it's like, oh yeah, this piece of hardware is just like, there's a race condition here, and I had to check, like, has it actually done this thing? It's fun. I enjoy being at the hardware level there.
Yeah. On a similar bent, there seems to be a pretty wide variety of like little displays as far as like getting started with that. Again, the MacroPad is a neat project in the sense that it has a nice display on it. And I did know it was an OLED display, which is great.
Yeah.
Are there other like small project ones that have a display like ready to go that people, if they're interested in like displaying some of the information from a sensor like temperature or things like that, that would be a good starter?
Yeah, I'm not sure. So displays are one of the areas that have been having a lot of availability issues due to the chip shortage.
Oh, really? Okay.
And so there's kind of like, I guess, 3 classes of displays. I would say OLEDs, TFTs, and e-ink.
Oh yeah, e-ink is like the ones that are used for like a Kindle book kind of reader kind of thing.
Right. And smaller versions of those are really common in grocery stores as price tags.
Yeah, okay, I've seen that. Yeah.
And so I think that's largely why the e-inks that we have at Adafruit, they're all kind of like price tag e-inks. But I think that the TFT section of stuff has been like pretty hard to come by. I think that's the shortage has been pretty tight on TFTs, which is why the MacroPad has an OLED.
Okay.
Which is it means it's a single color rather than full color. But it's like OLEDs the pixels themselves produce the light. And so they're really great in the dark because there's no backlight behind it.
Yeah. Okay.
OLEDs are great. They're just not like full color things. Some other products, but I don't know availability, like the Pi Portal is a device that's kind of meant to sit on your desk and like show you stats and things.
Yeah.
It's Wi-Fi connected as well, so that's an option. We have Pi Gamer and Pi Badge that both have TFTs on the front, and then also the Clue. The Clue is a microbit form factor board, but instead of the like LEDs on the front, it's got an actual display instead.
Okay.
So those are all good display options. And what we've done in CircuitPython is that CircuitPython, because we have those builds per board, we can know that like, oh, you have a built-in display. And so what we'll do is we'll actually show you the serial output on the display by default, which is great because seeing error messages can be tricky if you haven't figured out how to connect to the serial output. So it's very handy to have a built-in display.
Yeah, troubleshooting built in. That's nice.
Yeah, it's pretty neat, and it gets towards that like Commodore 64 era sort of computing experience that I was talking about earlier too, of like, I can see what I'm typing on this tiny screen.
Yeah, cool. I saw a couple things come through the stream recently on Twitter of Adafruit's stream of stuff. And one is you guys have an electronics show and tell Wednesdays?
Correct.
And so tell me a little bit about that.
Well, that's how I got the job.
Oh, okay, cool.
So for a long, long time, Adafruit's been doing their show and tell. It's a half an hour. We did do an hour for a while during the pandemic, but we're back to a half an hour where you can just join the video chat and show off your project. And it's run by Phil and Lamore usually, who are the folks that started and run Adafruit. So when I was doing my drone stuff, I was going on there kind of every week and showing off like the drone stuff I had done. And then when I realized that's not what I wanted to do, I went on there and was like, hey, I'm looking for a job. And the next day I got an email from Phil, and the rest is CircuitPython history, I guess.
Oh, that's great.
So yeah, I always encourage folks who want to get more involved in our community to join that show and tell. And then it's at 4:30 Pacific time,
Okay.
which is 7:30 Eastern. And it's followed up by Ask an Engineer, which is an hour-long show where they cover top secret stuff that they're doing, news from around the web, all the new products that went into the store that week are covered.
Okay.
In the Ask an Engineer time as well. And that's right after.
And there's an event we're going to probably come out just past it that's sort of celebrating CircuitPython as CircuitPython Day.
Right.
Which is the 6th of August. You said that it may vary the day.
Yeah.
Sometimes.
I think we were in September last year.
Okay.
It's kind of like, what are we feeling? Are people around? Do we want to do it then? So we're just going to be doing some extra streams, and we'll show off any projects that people have done, or it kind of originates from Arduino Day, I think. And they actually do like physical meetups for Arduino Day as well. And there have been some CircuitPython Day meetups that folks have done too, but generally on the Adafruit side, we just kind of like facilitate it and then we do some streams. So I normally stream Fridays at 2 p.m. Pacific on the Adafruit channels.
Yeah.
So I'll be doing that, and it's being advertised as a special edition, but I'm not sure how I'm going to make it special. So
okay.
By the time folks listen to this, hopefully I'll have figured it out and made it a special stream. But yeah, we're going to do there'll be some other streams that are not regularly scheduled on CircuitPython Day as well, to kind of just highlight everything.
You kind of use multiple channels when you do that. At least I noticed that as you were doing it. YouTube seemed to be the simplest one for me. I know it's being like rebroadcast on some other tools. Are you on Twitch, or is it Discord, or what are the other ways that it's sort of being connected?
Right. So we have a Discord server, an Adafruit Discord server that we've had for 4 or 5 years now, I think. We were relatively early on that boat.
Yeah.
We started that because I was finding as I got more involved in Adafruit that there was people that I was chatting with during these live streams on a regular basis. But the problem with the chats, especially YouTube at least, is like the chat goes away when the stream is done. And so at some point somebody said, look, we should have a Discord server. And I was like, I can make a Discord server. And we're over 30,000 accounts now.
Nice. With
like 3,000 people kind of logged in to Discord generally who are on our server. If folks want to join it, you're welcome. It's the URL adafru.it/Discord.
Okay.
Or discord.gg/Adafruit will get you there too. Cool. So that's one place. And then the live streams, the way that we live stream is we use a service called Restream that I use OBS on my computer. So OBS connects to Restream, and the Restream connects to YouTube, and Twitch and LinkedIn and Periscope, which is Twitter.
Yeah.
For a while we were doing Facebook, but there's like credential issues. So yeah, we get the streams going a lot of places.
That's nice.
And there's a lot of chats to pay attention to, but
that's what I was watching you do. I'm like, how do you do that? You're pretty skilled at it.
It's taken some practice. And so usually on my stream, it'll be at least YouTube and Discord. We get a lot of folks watching on YouTube, so it makes sense to do that. And then off screen, I do actually have the Restream chat, which is actually, it aggregates the other two services. So
nice.
I can see Twitch messages and LinkedIn messages there as well. They just won't show up on the stream, partly because I have more trouble moderating those messages.
Yeah.
So I wanted to make sure that I can moderate the messages that are on the stream.
And then I guess it's a little less ephemeral in the sense that you can keep the log of all those messages as it went to.
Yeah.
On the Restream, or not?
I guess I don't keep those. Usually the volume is really low.
Okay.
And if it's a question or something, I'll usually read the question off anyway. Because I think because my stream is so long, it's like tends to be 2 hours or so. I know that people aren't like watching with their eyes necessarily. So I do try, if I'm going to answer a question or there's something in the chat, I'll try to read it off so that people who are doing something else and listening in like can follow along still.
Nice. Mm-hmm. Cool. I have these weekly questions I like to ask of everybody. And the first one is, we've talked about what you're excited about in CircuitPython and the developments there, but what are you excited about in the general world of Python itself?
I think I'm very excited to see more people come to Python.
Yeah.
I've seen some people be hesitant about how many data scientists have come into the CircuitPython world. But, as somebody who is trying to be on the forefront of bringing more people into programming and understanding computers are not magic, and the decisions that computers are making are because a human told them that was a good decision to make. I'm really happy to see our Python grow with a wide variety of people who are working on it. I think my partner is a data scientist, and I think data scientists are soon to rule the world because we see so much AI stuff. And the people who are deciding whether an AI is good or not, or doing a good job or not, are data scientists. So I'm very excited to see Python be an ambassador for computers and programming to fields that are not just programming.
Yeah.
And hardware and software, and CircuitPython is definitely part of that as well.
Yeah, cool. So what's something that you want to learn next? It doesn't have to be Python specific, but what are you interested in learning next?
What I want to learn next? Well, I already talked about the Raspberry Pi stuff. That is definitely part of it. And maybe I'll talk about non-CircuitPython stuff, which we talked about before the stream as well. But I've been really digging into how internet systems work, so how broadband works. And I've been learning a ton about both policy, so particularly public broadband policies in the United States, and how cable companies have messed with that, and how certain organizations in the US are doing a really good job of providing high-speed, affordable broadband to everyone. Because, like my previous answer, like I'm a very big believer in the power of technology, and having internet access, everyone having internet access is critical to that. And so I've been learning a lot about how broadband systems work and how legal systems around that work, and how you could potentially start or run or do an internet service provider for folks so that everyone can have access.
That's awesome.
Yeah.
Do you have any additional shout outs that you want to give or plugs?
If you liked what you heard about Adafruit, I am sponsored by them, meaning they pay me to work full-time on Adafruit or on CircuitPython, which is all open source. And Adafruit pays the bills and my bills via open source hardware. And what that means for hardware is it means that you can see how all of the things on a circuit board are connected together. And you can actually take the files that produce the circuit board and modify them yourself. So if you're new to the idea of open source hardware, it's a good thing. And Adafruit is one of the leaders in the open source hardware world. So if you want to support them and me, there's kind of two ways to get into it. Adafruit.com is where you can go to purchase stuff from Adafruit. that's where you can get these circuit playgrounds, either the Express or the Bluefruit, like we talked about. But the other way I like to encourage people to get into this, if this is something that sounds interesting but you haven't yet, is actually go to learn.adafruit.com. I talked about the origins of Adafruit, and it's all in these guides, which are tutorials on how to make something. And so Learn is really cool in that it's all of the tutorials that we maintain that show you all the different things that you can do with stuff that you can buy from Adafruit. So if you're not sure where you want to start, learn.adafruit.com is a great place to go and just browse and find that MIDI pedal that piques your interest. And, it is advertising for Adafruit. So what will happen is that you'll see all of the instructions, all of the code for doing this project, but you will also see all of the products, and you'll be able to add them to your cart from there. And that's the best marketing I think there can be, is to teach you how to do all of that. So that's a great way to get into hardware as well.
We were talking before also that you guys have this thing called the Ada box, which is
right.
Is it quarterly?
Ish.
Maybe you can tell us about that. Okay. Ish.
Yeah.
Okay.
So AdaBox has had some struggles with like chip shortages and COVID. So AdaBox is a subscription service that Adafruit does that tries to be quarterly, tries to be every 3 months. And it is a box where we put something cool in it, and we'll teach you how to do a number of different things with it. Let's see. Circuit Playground Express was one of the earliest ones.
Yeah.
One of the more recent ones is we have a product called the MagTag, which is a Wi-Fi connected e-ink screen that you can put on your fridge. So it has like magnetic feet as part of it in the box as well.
Oh, okay.
So it in some ways kind of is like a mini Kickstarter every 3 months from Adafruit, but kind of like one of our core flagship things in that box every 3 months. And I did give caveats that it's not always every 3 months, but don't worry. We don't charge until we're actually shipping. So if we ever do miss our mark or push back a box by a month, you just won't get charged until it's actually ready and shipping.
Cool.
So that's what AdaBox is. And if you pay a bit more attention, we do tend to gear the stuff that we're working on in CircuitPython towards upcoming AdaBoxes. Maybe it's a little bit of a dirty secret, but we do it is meant as a forcing function for kind of like us to get our software side of things set for the sorts of projects that we want to do.
Nice.
I think Adafruit's success has largely been because it's very project driven, and like, how can we write a guide, and then what do we want to do, and what software and hardware do we need to be able to do it?
Yeah.
And that's a really good way to do it, I think.
Absolutely.
It's useful for something at that point.
Yeah. So do you have any, we mentioned a lot of the different streams and other ways that people can kind of find you online.
Right.
Are there any other social connections you want to share?
Well, I'm on Discord. I go by Tannewt online, TANNEWT. It was randomly generated in like 1999 and not taken.
All right, great.
I was almost I can't wait, which I kind of wish I just stuck with, but I think somebody had like already had it on Twitter or something. So I was like, I'm going to come up with something else. But I've been that for a while. So my personal website is tannewt.org. It's kind of old and not updated. I don't even know if it says that I worked for Adafruit for like 5 years. So I should update that.
Okay.
But I'm Tannewt on Twitter. I'm Tannewt on GitHub. So you can find me that way. I'm Tannewt on Discord as well. And if you want to stop by, we do the streams 2 p.m. Pacific on the Adafruit channel. So youtube.com/Adafruit is where we stream every Friday, almost every Friday on at 2 p.m. So those are all great ways to get a hold of me if you want to jump into this awesome community of hardware and software.
Yeah, definitely. Hey, thanks so much for coming on the show. This has been really great.
Thanks for having me.
All right.
And putting up with a bunch of garbage trucks.
Yeah. Don't forget, you can try out Rev.ai with your first 5 hours for free at Rev.ai. That's REV.ai. I want to thank Scott Shawcroft for coming on the show. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, Remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.